Welcome to the video on trig identities and ratios. So first we have our trig identities. Our Pythagorean identity is that cosine squared plus sine squared theta equals 1. So this is because in your unit circle, your radius is 1. So if we use Pythagorean's identity, we'll have this side squared, so cosine squared theta, plus this side squared, sine squared theta, equals this side squared, so 1 squared, which is just 1. So that's where your Pythagorean identity comes from. So you can use this for simplifying a lot of expressions. And then you also have double angle identities. So your sine of 2 theta is equal to 2 sine of theta times cosine theta. Your cosine of 2 theta is equal to cosine squared theta minus sine squared theta, or 2 cosine squared theta minus 1, or 1 minus 2 sine squared theta. So if you had the sine of 4/3, that's equal to 2 times 2/3. So your sine of 4/3 would be equal to 2 times the sine of 2/3 times the cosine of 2/3. So you can split it up into angles that are easier to use. Next, we have our trig ratios. So when you're given a trig ratio, it's possible to solve for the other trig ratios. So we'll go through our example and we'll look at each of these steps. So our example says if sine of x equals 2/3 and x is acute, find cosine of x and tangent of x. So first we'll draw a triangle. So we have a triangle here, and we'll label the reference angle. So we'll label this one as theta. We could choose whichever angle we wanted except for this 90-degree one. And then write the given ratio on the triangle. So our sine is going to be 2/3. So our opposite over hypotenuse is 2/3. So our opposite's 2, hypotenuse is 3. Now we need to solve for the missing side. So we'll use Pythagorean's theorem for that. So 2 squared plus this side squared, so question mark squared, equals 3 squared. So 4 plus question squared equals 9. We'll subtract 4 from each side to get that our missing side squared equals 5. So our missing side is going to be equal to the square root of 5. So this is the square root of 5. So now we need to find the cosine of x and the tangent of x, which we labeled as theta here. So our cosine of x will equal our adjacent over our hypotenuse. So square root of 5 over 3. And then our tangent of x will equal our opposite over adjacent. So 2 over the square root of 5. We don't want a radical in the denominator, so we'll multiply by the square root of 5 over the square root of 5 to get that the tangent of x is 2 root 5 over 5. So that's what you would do for that. Now we have our first IB practice question. It says simplify the following expression. So we have 2 sine x cosine cubed x plus 2 sine cubed x cosine x over 1 minus sine squared x. So in our numerator, we have a greatest common factor. We can pull out 2 from each. We can also pull out sine of x and cosine of x. So that leaves us with cosine squared x plus sine squared x. Our denominator, our 1 minus sine squared x, if we looked at our double angle identities, we'd know that that's equal to cosine of 2 theta, or 2x. Our 2 sine x cosine x is sine of 2x. And then our cosine squared x plus sine squared x is 1. So we have sine 2x over cosine 2x, and sine over cosine is tangent. So our answer for this would be tangent of 2x. So this whole big expression can simplify just to tangent of 2x. So that's why it's really important to know all of your trig identities, because you're going to need them to be able to simplify expressions like this. Now we have our second IB practice question, which is also no calculator. It says if cosine of x is 3 over 10 and x is acute, find sine of 2x, cosine 2x, and tangent of 2x. So we'll draw our triangle. We'll label angle x. And our cosine is 3 over 10. Cosine is adjacent over hypotenuse, so it's going to be 3 and 10. So 3 squared plus, we'll label this y, so plus y squared equals 10 squared. So 9 plus y squared equals 10 squared, which is 100. And then we'll subtract 9 from each side to get that y squared equals 91. So y equals the square root of 91. So we'll put the square root of 91 here. So now we need to find sine of 2x, which is equal to 2 sine x cosine x. So our cosine of x was 3/10. We can find our sine of x by looking at our opposite over hypotenuse. So square root of 91 over 10. And then we can go ahead and multiply these to get 6 root 91 over 100. The 6 and 100 can simplify to 3 and 50. So we get 3 root 91 over 50. That's equal to our sine of 2x. Our cosine of 2x, we could use any of the double angle identities that we were given earlier. So let's just use 2 times cosine squared x minus 1, because we were originally given our cosine of x. So this will be equal to 2 times 3/10 squared minus 1. That equals 2 times 9 over 100 minus 1. Our 1 is going to be equal to 100 over 100. So then we have 2 times negative 91 over 100. The 2 and 100 simplify to 1 and 50. So we get negative 91 over 50. So negative 91 over 50 is equal to our cosine of 2x. And then our tangent of 2x equals our sine of 2x over our cosine of 2x, which is 3 root 91 over 50 over negative 91 over 50. So these 50s can cancel, and we'll get 3 root 91 over 91, and that's negative. So our tangent of 2x is equal to negative 3 root 91 over 91. So there are your answers to that problem. In summary, our Pythagorean identity is cosine squared theta plus sine squared theta, and that equals 1. Our double angle identities are sine of 2 theta equals 2 sine theta cosine theta, and our cosine of 2 theta equals cosine squared theta minus sine squared theta, or 2 cosine squared theta minus 1, or 1 minus 2 sine squared theta. For our trig ratios, we draw our triangle, we label the reference angle, write the given ratio on the triangle, solve for the missing side, and then find the new trig ratios. That's all for this video. Thank you for watching.